Imagine standing in front of an ATM. You slide your card in, punch a few numbers, and wait for your cash. Do you have any idea what's happening inside that machine? Probably not. You haven't opened up the metal casing to inspect the circuit boards or trace the wiring, and you don't really need to. As a customer, your only concern is whether putting your card in results in money coming out. This exact idea is the foundation of a software engineering concept called black box testing. The software is treated like a closed, completely opaque box. The person testing the program cannot see the internal code at all. Because the code is hidden, the tester only has to focus on what the software actually does. They feed it an input and check the output. This means you can test the program exactly how a real customer would use it, requiring absolutely no programming knowledge. Let's look at how this works in practice by testing something we use every day, a standard login screen. Think of it like a digital vault door. The tester starts with the obvious approach. They type in a correct username and a correct password. The software processes it, and they check to make sure the screen says login success. But people make mistakes, so the tester also tries to break the door. They try hitting enter with an empty password. They paste in an extremely long password. They type in random special characters. For each of these weird inputs, they check to ensure the software responds safely with an error message. Notice what the tester isn't doing. They are never looking at the actual code written by the developers. Their entire job is to verify that the final result matches what the user expects to happen. This approach guarantees the software behaves properly on the surface. But because nobody is checking the engine under the hood, hidden logic errors or security flaws could still be lingering deep inside the code. So, how do we find those hidden flaws? We have to stop thinking like the person trying keys in the door and start thinking like the locksmith who built the locking mechanism in the first place. This introduces our second approach, white box testing. Imagine taking that opaque black box and swapping it for clear glass. Now the tester can see absolutely everything inside. Instead of just checking if the output is right, the tester is verifying exactly how the software reaches that output. They are looking directly at the functions, the instructions that repeat, and the specific conditions that make the program tick. Because you are reading the raw source code, you can't just be an everyday user. This type of testing requires deep programming knowledge, which means it is almost always performed by the developers who write the software. Let's see what a developer actually does when they open up the code. Imagine a simple algorithm designed to check a user's age and determine if they are legally allowed to vote. The developer looks at the very first line of the program. Here, the code creates a simple container, a variable, meant to hold the user's age. Next comes the core decision point. The program asks a simple yes or no question. Is the number inside that age container greater than or equal to 18? If the answer is yes, the code flows down one specific path, triggering the function that allows the person to cast their vote. But if the answer is no, the code is forced down an alternate path, triggering a different function that rejects the user. A white box tester takes these lines of code and transforms them into a visual map. They look at this branching logic and actively test both the yes path and the no path to ensure neither route crashes the system. By deliberately forcing the program down every single logical branch, the developer ensures every part of the code is actually used. They eliminate dead ends and catch hidden logic errors long before a customer ever touches the software. If you ever sit down for a software engineering interview, you will likely be asked a very specific question. Between black box testing and white box testing, which method is actually better? Let's line them up. The table shows black box is the user's view, verifying overall functionality without programming skills, making it perfect for testers. White box is the developer's view, verifying internal logic by inspecting source code, handled strictly by programmers. So the answer to the interview question is that neither method is universally better. They aren't competing with each other at all. They measure entirely different dimensions of the software's health. That is why professional software teams never rely on just one or the other. They weave both methods together into a single continuous pipeline. First, the developers use white box testing to confirm that the internal code is structurally sound and free of logical traps. Then they hand the software over to testing engineers. These specialists use black box testing to verify that the program actually behaves the way a human being expects it to. White box testing ensures the machine is built perfectly on the inside, but it takes black box testing to prove that this perfectly built machine actually solves the user's problem.